Okay. Assalamu alaikum. My name is Narjes Abu Zarifa. I am research student at School of Housing, Building and Planning at University of Science Malaysia. I am from Palestine. I already submitted 2 papers to the conference. The title of first paper is A Method to Calibrate Daylight Factor at Inclusive Internal Corridor using Scale Model and Simulation. Okay, as introductions, internal corridor is a form of hallway or gallery which is typically narrow in comparison to its length and acts as a passage connecting different parts of a building. However, the vast majority of today's corridors are designed without any adjustment to the lighting system other than to just turn them on or off. This is because hallways or corridors are viewed as a little more than passageways into other areas of the building. Hallways or corridors don't get a lot of consideration when it comes to interior design, specifically interior lighting. So, the problem statement of this study is inclusive corridors are long, and they usually have no window and require artificial lighting to be switched on for 24 hours continuously to operate. Some corridor designs have openings for daylight at the end, while others supplement daylight at the middle. The most part of these corridors are dark and consuming a lot of non-renewable energy from artificial light. The objectives of this study The main objective of this study is to explore how inclusive internal corridors or hallways do get the benefits of daylight depending on the corridor designs. Also, this study intends to experiment with how intense inclusive corridors can be broad daylight to solve for the problem of them relying 100% on the artificial light. So, the methodology of this study used is experimental research. Experiments are conducted at University of Science Malaysia, environmental laboratory, the artificial sky, fieldwork measurement, carried out for validation of research. The scale physical model was structured to be tested under artificial sky conditions. The same model was designed in the Radiance software to test daylight simulation experiments. So the results of this study, as can be seen in the fieldwork data, daylight factor from the artificial sky model and the radiance simulation model was found to be in similar pattern with the fieldwork data with differences of less than 10%. Therefore, one can conclude both the artificial sky scaled model experiment and the radiance simulation could further be used to expand and further study on corridor lighting with confidence. Overall, the integration of daylight into deep spaces is an essential feature of building design when done properly with which careful planning. Using natural light as much as possible is important to preserving the environment and supporting human health. This study explores how inclusive interior corridors do get the benefits of daylight depending on the corridor designs. It explores how daylight factor less than 1%, specifically in Malaysia, where the skies are bright, can be beneficial and useful. The innovation required for corridors are minimal according to standards. Results show that the reading calibrate will between fieldwork data compared to the scale model in artificial sky and simulation with less than 10% differences. It was found that values of daylight factor of 0.5 and below calibrated well. Comparison were also carried out in terms of absolute illuminance, and it was found that daylight illuminance less than 40 lux in corridors should not be underestimated and were still useful, even though lower than the usual standard of corridor illumination. This successful calibration will be used for further experimentation how inclusive corridor can be naturally light by simulation. Here I am going to talking about second paper. The title of this study is Wall Design for Broad Daylight in Inclusive Corridors. Okay, as introductions, corridors are often dark spaces and completely depending on artificial lighting for 24 hours per day. Therefore, this leads to the consequence with huge increase of energy consumption that has several direct and indirect harmful effects. To reduce the use of energy for lighting, one of strategy is reducing indoor artificial lighting and optimize day lighting. One of the strategy used to optimize day lighting is use of broad daylight technique. Broad light is a term used to describe the lighting of an inclusive internal space through a window that connects to an adjacent daylight space. Broad light rarely brings much daylight into the internal space, but it does provide a connection with outside and can be useful when the amount of the light required in internal space is less than in the daylight space, for example in corridors or hallways. Therefore, the purpose of this study is to examine how lighting internal corridors can be achieved by the broad daylight technique. So the problem statement of this study is corridor walls are usually opaque resulting in very dark situations relying on artificial lighting. The objectives of this study are to further investigate the extent of daylight which can be borrowed to light the internal inclusive corridors. So the methodology of this study is the experimental using computer simulation method. This is because data inputted into the program can be easily accessed and changed whenever required. This is carried out by experimenting on the different type of corridor wall designs with added transparent of glazed areas for daylight to be brought to the inclusive corridors. The designs experimented with different horizontal and vertical alternatives. From the graph, which compares the vertical alternatives, results show that the daylight factor performance would depend on where the vertical strips are located in the corridor under study. So in these graphs above, the performances of all the cases were compared and ranked, compared to the base case with all opaque walls. So the effects of these new corridor wall designs to daylight distribution in corridors are investigated by radiance simulations. Results are compared to base case, which is a situation of all opaque walls for the corridors as the worst situation. According to the results, it is clear that using 4 strips which are 50% of the glazing area as shown in graph, is optimum design for the corridor wall. That is found to be the best design for allowing the most daylight to be buried.